known as go-to-market strategy, right? How to develop the product fast and deliver it to the market, correct? So agile is there everywhere. Now, having said that, in our introductory lectures, I said, hey, if I'm doing a project, let us say in healthcare, let's say I'm doing some kind of an automation system which determines how much dosage has to be given automatically to patients. I would be a little bit more careful in doing agile there, right?
Yes, sir.
See, the higher the risk, the process becomes more deliberate. Deliberate ante we spend a little bit more time, correct?
Oops.
We cannot, for example, let us say if we are developing drug development, the drug development life cycles in the pharma industry, which is all run through software and all that, it has a longer development life cycle because those drugs, when introduced into the market, would affect the lives of millions of people, right?
Yes, sir.
So in those situations, I would be a little bit more careful,
Okay, sir.
right? But let us say I'm developing some IT system for your JNTU Kakinada.
Yes, sir.
Okay, I can use agile there. There's no life, there's no risk of life or anything like that. Got it?
Thanks, sir. Okay, sir. Thank you, sir. Thank you very much.
Welcome. Okay. I'm just sharing this screen because I wanted to show you before I go instead of the quote. So this is the conference. These are all like professors from different places. One of the things I wanted to show you was we are doing a special, yeah, this is what I understand. See this gentleman here? That's Professor C.V. Ramamurthy garu. So he is my PhD supervisor and he's a Berkeley faculty. So I think I mentioned to you about him, right, in the beginning. So we are doing a special session on him. I was actually supposed to take him to Dallas with me. He's too old now, right? He's like 89 years old. But last few weeks he fell very ill and he's in the hospital. So we're doing a special tribute to him to celebrate him there. So that's one of the reasons why I'm going there. And that's why I'll be missing next Wednesday's class. Okay. I assume Aditya students have come. Tirmal Raghav, I'll start the class now. Chakravarti, it's okay? Good morning, Andy.
You asked something I missed that.
Andy?
Sir, ఏదో అడిగారు వినిపించలేదు.
Pandi.
Sir, you mentioned my name.
Yeah, whenever you people are ready, I wanted to start an antakante.
Yes, sir, we can start.
Okay. So what we'll do, students, I'm glad that people are liking the class and there's some benefit to it. We lost some precious time because of the Dasara vacation. But that's okay. That is, and then of course you have a lot of placements. But I'm glad we covered the full life cycle of the software development. Whatever little I'm going to share with you over the next 2 or 3 lectures is all like, call it like the icing on the cake. Okay. So one chapter that I wanted to cover was dependable systems. Right? Whenever we want to develop a system, it better be complete and accurate, right? Something can depend upon for accuracy, for completeness, for a lot of other attributes. So this is going to be a little bit theoretical for you, but it's worth noting the important concepts out of this chapter. The other chapter after this that I wanted to cover is on security engineering. So I wanted to cover some aspects of security for two reasons. Number one, there's no system that is developed today without talking about security. Security is an inherent property of any software development. So it's good to get a little bit of overview of security. There's a good chance that I might offer a full-fledged course on security for JNTU Kakinada in the future. Next semester also I'm offering one course. I don't know if Murthy Garu already shared that information with you or not. The Vice Chancellor and Murthy Garu and all these folks asked me if I could offer one more course for you. They are going to send me your core list. I will select one of the courses from the core list and I'll offer that. Okay. If you have Chappan Murthy Garu. Okay. So just giving a heads up to other faculty members there. So you have to put up with me for one more semester. So okay. So having said that, let's get into dependable systems here. Okay. So we'll look at what we mean by dependability. Okay, first and foremost. And the word socio-technical is an interesting term because the whole idea now is whatever we do, it should benefit the society. That is the bigger scheme of things. So we'll look into some aspects of that. And then we get into things such as redundancy and high availability. Redundancy means like when one system fails, there are other systems which can fire up, right? That's the redundancy. We'll talk about that. The dependability should extend to processes also that you have. Okay. For example, when you develop a software project, there's a certain process. Let's take our own set of students here, right? When I asked them to do agile methodology, all of them followed a certain process. So the process is well defined. So we'll talk about some elements of what those process models are, standards like CMM, and so on. Okay. Okay. Now, having said that, Aditya is ready. Okay. Okay. So, what does at the very base? Forget this slide here. In our daily lives, right? Let me make this small here. What does the word dependable mean in your regular day-to-day context? So when I say, let's say, when somebody says, let's say the Vice Chancellor says, Murthy Garu is very dependable. You all know who your Vice Chancellor is, right? That might sound like a stupid question to you here, but a lot of students in universities here may not know who their chancellor is. When your Vice Chancellor says, Murthy Garu is very dependable, what does he mean by that? Who wants to take a guess on that? Oh, somebody said they are giving gifts for 5 students from each college. Wow, that's a lot of people. Okay, that's good. Okay. Anyway, going back to the lecture here, what does, by the way, this question is open to faculty members too. GC or Aditya, please feel free to jump in. When your vice chancellor says Murthy garu is very dependable, what does it mean? Chakravarti garu cheppandi, I know your microphone works quite well.
Yes, sir. So Murthy garu will do any assigned work without any failure.
Correct, right? That means trustworthiness, right?
Trustworthiness, yes.
There is trust. Okay, and then when you say Murthy garu is very dependable, trust with respect to what? Trust with respect to the work related to the university stuff. Correct?
Yes.
Kada?
Yes, sir.
Okay. So for example, putting together new curriculum, putting together MOOCs classes, right? Developing some IT systems for automation. All of those things, the vice chancellor knows that it is given to them, given to him, it's done. There's trustworthiness. Now,
Sir, though you are telling as example, but it is true in our case with JVR Murthy garu.
correct, correct. No, but I'm also going to make a joke now, uh, where we'll all laugh with him, not at him, but with him. Okay. Now, మీరు మూర్తి గారు నో అఫెన్స్ మెంట్ అండి. Okay. Always tell my students like I'm a very sloppy guy. I'm actually very sloppy and lazy, for example. You would not believe it. People tell me, Pratap, how can you get up at 5:30 in the morning and keep working till 12:30, 1 a.m. in the night? And at the same time say I am the most lazy guy, right? I am, believe me. ఇక్కడ ఏంటంటే ఇప్పుడు going back to this one, he's trustworthy with respect to what is required for JNTU. But the vice chancellor is not making any judgments on him what he is outside of JNTU environment, right? For all you know, he could be అదేంటది మన తెలుగులో ఒక సినిమా ఉంది, ఇంట్లో రామయ్య వీధిలో కృష్ణయ్య అని. I remember that from long time ago. I don't know how many of you know that movie. We don't know whether he is a very religious Ramudu lanti person, Krishnudu lanti person, we don't know. But I wouldn't care also, because that has nothing to do with my JNTU system, right?
Yes.
So it is trustworthiness in the context of what is required for our environment. That is the key there. So when we talk about system dependability, that system is supposed to perform what we require of it in our environment. Let us say you are developing a system where the system is automatically grading the students' papers. Remember in my Lensu system, I showed you in the beginning that the quizzes are graded by the system automatically. So it has to make sure that it can grade correctly. That is the trust that we need to have. Okay. Okay. Now, why do we need to care about dependability? Because people get impacted. Imagine your grading system fails all the students. I think you will have a fairly large group of students who will be very upset. Okay. Same thing, if they are not reliable or unsafe or insecure. Ikkada, one of the latest things that is happening in high schools in the United States is the following. that the students, high school students, can do very good coding, right? Here they hack. What they are doing, some of these high school students, they are going to the high school IT systems and changing the grades. A grade ఉన్న వాళ్ళకి B grade చేయటము, B grade వాళ్ళకి A grade చేయటం అలా. Real nuisance అయిపోయింది that because most of the high school grading systems and all that, they are very easily hackable. If you know how to hack into systems, it's very easy. So it's not a secure system. So we want to make sure it is secure, right? And if the system fails, there's a very high cost. I'll give you one very practical example. In UC Berkeley, about 10 years ago, somebody in the finance department lost the data related to all the students. Okay. Now what? About 35,000 students, 40,000 students. In this country, if you lose that, there's a big liability. UC Berkeley had to send all of them express mail, FedEx. India lo kuda FedEx undi kada, next day delivery. Each FedEx mail costs about $15 to $20. So if you extrapolate it by about 40,000 students, that is how much, Andy? 40,000 times 20, 800,000. So $1 million it costed UC Berkeley to inform all of those people. Same thing happened to HP employees. HP had 150,000 employees. I was one of them. And our 401k administrator, their system was, the data got lost. Fidelity. They had to FedEx to 150,000 employees. So there's a cost associated with those kinds of failures. Okay. So that is why it's important to build dependable systems. Okay. Now we know we have established that dependability is an important criteria. Now, what kind of failures can happen? It can happen all over the technology stack, right? Remember, we talked about a technology stack in one of the introductory lectures. If you look at the technology stack at the basic level, the foundation is the hardware. Hardware can fail. Now, hardware without any software is useless. So software would be there, software could fail. Software could be the application software, or it could be the operating system too, right? If you look at Microsoft operating system, it's more robust now, but in the good old days, it used to fail quite often. That is the reason why Mr. Bill Gates was known by the nickname Control Alt Delete, right? In the good old days, in the conferences, when Bill Gates used to be there as panel speaker, people used to kind of jab at him by talking about Control Alt Delete. He used to get very upset. It's a hard reboot, right? Almost. Hard reboot is really power button, but it's kind of close enough. Okay. And optional failures can happen. Right? People can actually lose jobs when these things happen. Okay. Now, dependability comes in various shapes and forms, many parameters, right? So if you look at the parameters here, I would not say these are the only parameters, but these are some important attributes, right? I always say dependability is business context driven. Okay. So let's look at some of the properties here, right? By the way, when I'm talking, if students have a question, please ask them to put it in the chat window. Okay. So availability, and the system should be there to deliver the services when requested. When I'm ordering a book, if you have Amazon, you select a book. You all have ordered books from Amazon, right? Most of you. What do I do there? I go search based on ISBN number or author number. Then I do a checkout. Okay. Now, once I do a checkout, Then it'll ask me for my credit card information. I enter my credit card information and hit return. What do I expect when I hit return? Anyone can answer that. So I didn't check out of the book. Then I want to purchase, so I give my credit card information. What is the expected behavior of the system at that point of time? It is going to process my credit card information and then display some confirmation, right, on the screen. Here is your confirmation number. Transaction successfully processed. Okay. What happens if the system does not give me that confirmation message? That could be one example of system not being available correctly. Okay. That can also be kind of looked at from a reliability perspective, because reliability talks about the ability of the system where it is performing accurately what it is supposed to perform. Okay, like for example, grades. If your system is going to compute the grades, ikkada, for example, in US, anything above 90 is A grade, at least in my classes. So if the system says this guy got 95 but the grade is B, then that is not a reliable system. Sometimes it gives A, sometimes it gives B. It's not a reliable system, right? It should give the results accurately. That is reliability. Okay. Safety. Safety is where, for example, the system should be up and running all the time. Okay. Without any catastrophic failures. Can we ensure safety like that all the time? Probably not. It also depends on the business context, right? I do not know if you remember stories about eBay going down suddenly for 3 hours. Last year, I think Gmail went down for half a day. Okay. So it is a failure, but we don't want those failures to happen. Security, I already gave you the example of security, right? For example, if you have patient health records and unwanted people can gain access to the patient health records, that's not a secure system. Okay. Now, at the very end, you see resilience. Resilience, ante, what does it mean? When any of the failures happen, okay, it's like we try to prevent them as much as possible, but if something fails, we should recover fast also. That is the resiliency. Like a lot of times, hackers conduct what are known as denial of service attacks. That's what happened to eBay a couple of years ago. They unleashed a denial of service attack on eBay. That means to do. Okay. But eBay had enough systems in place, processes in place, where they were able to recover from that quickly. So that shows the resiliency. Okay. Any online transaction processing systems, whether it's airline reservations or in India, you have Indian Railway reservations, right? You can imagine when it goes down, the impact it has on the economy of the country. There are some studies which have been done. When eBay goes down for 30 minutes, it costs the US economy $3 billion, billion with a big B. Okay. So whenever you're developing systems, these are all the properties of dependability that you have to take into account. Okay, let me pause here, and if any of the faculty members or students have questions, comments, go ahead. Correct. 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 Yeah. So that's good. Glad you caught that point. You're right. Any other comments, questions? Tirmal Rao garu cheppandi మీరు. You are quite.
Yes, sir. Actually, I remember in 1999 when I was studying, Yahoo was hacked, if you can remember, by distributed denial of service attack. For 1 week, Yahoo was
Absolutely.
stalled, and it
Correct.
costed, I don't know how many million dollars, but it costed a lot to the organization itself. They had
Correct.
HTML, if I remember. At
Correct.
that time, Java applets were on swing.
Correct.
That's what I still remember. And then in somewhere around late 90s, one bank's website was hacked by an individual hacker, where he has already, I mean, he has taken almost 30,000, users' credit card credentials. He wanted to negotiate with the bank, but the bank denied. But he wanted for each candidate $10 or something like that. But the bank denied, and it so happened that it has costed, like FedEx, as you said, it costed bank again to give a credit card. It costed them $25, and the CEO was fired once the incident was happened.
That is true. That's what you said is absolutely true. Actually, in my security class, I do a very interesting slide on that. I show all the hacker attacks. Anyone knows when was the first so-called hacker attack happened? Hacker or worm attack. It was called a Morris worm, Morris. You can actually Google him up. He was an MIT student or a Cornell student. On the Unix systems, we used to have what is known as finger and a command undedi. I can finger a person and see whether they are online or not. In those fun to see who is online, who is not online. But like a true geek, his code had a bug. He did not write perfect code. Then it unleashed an internet worm attack, which brought down the internet. In those days, entire internet was very small, right? It's not like today. And then he was, of course, caught. He was jailed. He was given penalties and all that. Of course, later on, he got a fantastic job in a big company because he's a brilliant programmer, right? So, so these kinds of things happen. Every single day, there are hackers all over the world. When I say hackers, they are not all bad people. Don't get me wrong. By the way, you all heard about cyber attacks, right? There are so many attacks on government systems, whether it's US or China or India. I'm sure there's a special wing in Indian government somewhere. They're trying to hack into Pakistan IT systems, and Pakistan must be doing the same thing to India. Those things happen all the time. See, somebody is already putting that Robert Morris, launched on November 2, 1988 from MIT. That's when the birth of it happened. Okay, great. Let's move forward. Okay. So ఇక్కడ definitions అన్ని ఉన్నాయి. You can read about it. I talked about it. Right? See, as Thirmal Raghav said, he talked about distributed denial of service attack, broad classification of denial of service. Now, interesting thing about denial of service is, denial of service does not mean the system is up, but is not able to process your requests. Kind of imagine if you go to Amazon and you are doing that, the moment you give your credit card, it takes forever for it to give you a confirmation message that your order has been processed. That is a denial of service attack. What it basically means is the hackers unleash certain viruses or worms which would slow down the performance of the system. That is why it is not able to perform its operations optimally. Okay. Okay. Um, so how do you achieve okay? Uh, but by having systematic processes, development processes, we can at least have some kind of an insurance that whatever we are developing meets the dependability metric for that application. Teams should have very strong validation and verification processes. That means your QA and testing team should be very strong. Okay. Let me ask a question to the students here. In the industry today, who gets paid more, the QA testing guys or the developer? Who gets more salary? Is it the programmer or is the QA testing guy? Somebody said testing guys get more. Ideal said testing guys get more. Do you all agree with that? Who will get more? Developer. Yes. Correct. Possible. That's possible. But if you compare apples to apples, a developer usually makes more money than a tester in general, right? Not at the lead level, but normal developer to normal tester. Okay. Now, I'll give you a counter example for that. Because remember here we are saying verification validation is very important, right? To develop dependable systems. How come they are getting less, paid less? That's unfair. My professor Ram used to tell me the verification and validation engineers at Boeing, the big Boeing company which produces planes, the QA testing people, they always were getting paid more than the developers. I'm just giving a counter example to that. Right. Exactly, you got it. Correct. Whatever you said is absolutely correct, right? So that is why that example actually gives us great insights, right? So the student should never think, oh my God, I only want to be a developer. There is a perception in the industry where it's like cool and sexy to be a developer as opposed to being a QA testing person. Nothing wrong, right? You choose your profession based on your interest and your skill level, right? Some people are phenomenal in QA testing. Like they are fantastic in finding faults. Okay. So they will shine in that field. Nothing wrong in it is never based on, oh, only developers get paid more. Your skill is great, you'll get paid commensurate with your skills. That is true. It certainly makes, I mean, rule of thumb, right? Rule of thumb is an average developer makes more money than an average tester. You are absolutely right. Uh, but the reality is, I'll give you an example. Like today, when I teach courses, some courses that I taught for the Saudi students, right? When I'm teaching those courses, I used to take my engineer with me to my class. Remember, I ran a company where a product, right? My hotshot Java engineer used to come with me last year, and I used to tell the students, you have to install this IDE, right? Remember, integrated development environment. Uh, when I used to tell them, hey, if you have any difficulties in installing and configuring, here is my engineer. Talk to him. He can fix those problems for you. I am no longer capable of fixing those problems quickly. Um, because it's a little bit complex. I no longer do hand programming, right? Day in and day out. So I used to tell them, hey, my programming skills and debugging skills now on a scale of 1 to 10 are probably around 6. Yes, I can still program as a university professor, but can I have to be honest to myself, right? So whenever we are doing these things, we have to choose based on our skills. Just because someone else is a developer, we should not be a developer. If that is not my skill set, I would not do that. Okay. Now, configuring the system correctly is important. Okay. See this last one bullet, including system capabilities to recognize and resist cyber attacks. So there's some terms that we use here. You probably would have heard about these terms: intrusion detection. Am I spelling it correct? So there are intrusion detection systems. I misspelled there. There's an entire field called intrusion prevention and intrusion detection systems. Okay. Um, if you take, for example, we have teams in Cisco where we call it as PCERT, product. Let me see if I remember. Product security incidents response team. Okay, so the team which keeps track of all the intrusions that happen into Cisco day in and day out. We get hundreds and hundreds of attacks on our Cisco systems. Okay, so another thing that we use here, the terminology is firewalls. You all about firewalls, right? So all of these things are firewalls which try to prevent hackers from gaining access to the internals of your system. So whenever you want to develop dependable systems, that becomes a very you should recover after failure in the shortest possible time. Let me ask you this one here. I'm sure it's the same in India too, right? When you have banking systems, all banking systems have databases, right? Um, is there one centralized database or do you have the database which is distributed for banking systems? The database is distributed in a banking system. Distributed geographically. If you take banks in California, for example, they have a database, they have the data center here in, of course, somewhere in California, but they also have data centers in on the East Coast, for example. Why do they do that? Because California, for example, is earthquake prone. When earthquake happens, buildings collapse. Remember catastrophe, right? When buildings collapse, the data centers collapse. The systems may not work. The power outage could happen, right? Our databases somewhere else I can switch over to that other database. Okay, so in your database class, you would have learned about some of these concepts about high availability, right? And then how do you replicate databases? How do you keep them in sync? All those things would be part of designing and developing a dependable application or a system. Now, let me ask you a related question there. Do you think an average programmer, a regular programmer, would know how to do? Faculty members are welcome to discuss too, because it brings out some points. There's some important moral in the story here for that question. The question is, okay, you are a software engineer, okay, and we are saying we should develop dependable systems. Part of that strategy is we need to have a database strategy where maybe you have to replicate the databases, right? Now, do you think this programmer would have the knowledge to do all of those things? Let me ask the madam there, who I'm seeing in GEC picture. If your mic is working, please feel free to speak.
It's not working, sir.
Okay. Na question అర్థమైందా madam? Oh, she's putting in chat. Huh? I thought you are going to speak in the mic. I think your voice is more pleasing to the student than my voice. Maybe you should speak more. Okay. Yes, for what? That the programmer would have knowledge of all of those things? So I would take a different viewpoint. I would say it is humanly impossible for one guy to have knowledge end to end of developing a completely dependable system. That is the position that I want to take. Is there anyone there who wants to take a different position? Tirmal Rao garu gani, Chakravarti garu gani, Murthy garu gani.
I agree with you, sir. Programmer will have some basic knowledge about the programming. So he'll be doing security-based programming, not normal C or C++ programming. He's given C or C++. Like stack overflows and all he has to take care of, which may not be required for normal applications and all. Bounce checking and all, that should be very much stringent.
Stringent, correct.
Security level, he'll take care. But what is the architecture and all, how things works, it's a very superficial phenomena for him as a programmer.
Correct, correct. So that is the reason why whenever we get into these kinds of things like develop term and a senior project, it's another thing to really develop an enterprise industrial strength software for an enterprise, because it requires so many different skills in so many different subject matters that you are learning in your undergrad class, right? So a team typically consists of somebody who's really good in programming, somebody who's really good in analysis, somebody who's really good in communication because they can gather the requirements, somebody who's really good in the hardware architecture, right? Somebody who's really good in database design. So it's truly the collective wisdom dependable system. Okay, so the team lead or the project manager, one of the key roles for them is to identify all the right people. Then the project would be successful. Okay, so I just wanted to bring that point out. I mean, having said that, you'll always find some people who are good at everything, right? My dad used to tell me when he was doing his MTech in IIT Kanpur long time ago. Um, I mean, he went as a faculty member, right? QIP program in India, University Kanpur. And he used to tell me, I remember this. I don't know why I picked it up. One of the classmates that he had, his name was Sahasra Buddhi. Sahasra Buddhi means Sahasra means thousand, right? Buddhi. So he used to tell me he was really a thousand brain guy. He was that smart. Everything was easy for him. But how many people will be like that? Not many, right? So it's truly a cross-functional, cross-disciplinary team that really builds these kinds of systems. Okay. Now, wherever you talk about dependability, the more because let's say if I want a highly secure system, I have to hire a security analyst who understands security. Then security testing we have to do. Security testing is different from functional testing. I told you that in one of the beginning lectures, right? So the costs add up. Now, if you want to replicate machines, replicate databases, that means you're installing multiple licenses, multiple copies, and you need an operations staff to maintain all of those things. So you can see how the costs keep adding up. So dependability again is business driven. What is important to your business, right? How to absolutely important. So you have to do some kind of trade-off analysis when you talk about dependability systems. So here is a nice graph, right? So it's dependability versus cost, right? The higher the dependability, the higher the cost. Pretty standard curve that we see in many aspects of engineering. Okay. You can see here, right? It may be more cost effective to accept untrustworthy systems and pay for failure costs, which is true, which is a business pragmatic sense. I'll give one Visa, MasterCard, and all of those things, correct? Uh, do you think the Visa, MasterCard, and all are completely trustworthy? 100% reliable? You are protected? Probably not. I used to teach a security class where I used to give some statistics on how much Visa and MasterCard fraud happens. Okay. If you read your agreement closely with Visa or something, when there's a fraudulent transaction in your statement and you report anything about that, they'll take care of it. Okay. Now, can Visa develop a solution, a foolproof solution, where it can bring that fraudulent activity to zero? The answer is yes, if they want to. The cost of developing a system where the fraudulent activities comes to zero is so expensive. They would much rather catch those fraudulent errors when the users report and pay that. Let's say on your credit card bill, you see a $500 transaction and you don't know what the transaction is. And you're liable, the net loss is $450. So Visa would actually subsume that cost, whichever bank gave you that card, right? They would much rather pay you $450 instead of trying to develop a foolproof system because that is much cheaper for them. Okay. Questions, comments? So I'm going to take a 2-minute break here because I need to get something to drink. I'm thirsty, so give me 2-minute break, please. Stretch break. I'm putting it in the chat here so that way everyone knows.
ఒక నిమిషం మంచి పెద్ద షట్ అవుతుంది. దానికైతే ఓన్లీ మైక్ పని ఓన్లీ వాయిస్ వినిపిస్తారు మైక్ పని చేసి అట్లా ఓన్లీ ఒక్కనే ఉంటుంది సార్.
So while we are waiting for another minute or so, are there any faculty members there who have returned the awards to Government of India? There's some big movement going on in India, I believe, right now, where artists and other celebrities are returning. Okay, let's get to my presentation here. Okay, so let's continue. I'll speed up a little bit because it's pretty easy to understand. Key thing to note, we are no longer developing software which is isolated. Okay, it is going to be part of an overall ecosystem, right? Everything exists within an ecosystem. Now, when you talk about an ecosystem, in the ecosystem, you have human beings, you have some social type of weather system. Why do we talk about wilderness weather system? It's like trekking. You know about trekking, right? Even in India, it's very popular now, right? You go trek in the forests, mountains, Himalayas. Very important to understand the weather systems when you're trekking, right? So if the weatherman says something and you go trek, all of a sudden the weather is inclement, people die. When you're talking about building systems in such kind of an environment, that's why we talk about socio-technical framework. And the operating system, data, application, business, organization is enterprise, we understand that. But now we talk about going beyond organization. We talk about society. Okay, so one of the remember the organization that I showed you here? I think I was sharing my screen, right? The SDPS. I told you I belong to that organization. We do what is known as transdisciplinary. I'll put it in the chat here. Very useful for you, Andy. Transdisciplinary research and education. Students,
Sir,
you
can you
can
come out again, sir?
yeah. I was just giving this word called trans. Remember, I'm talking about society and all that now, right? When we talk about software engineering, the impact on society, the impact on organizations, and so on. So there's an evolving field in software engineering or systems development, which is called transdisciplinary research and education. Okay, or you can say research and development. Who are software engineers, architects, sociologists, scientists, community leaders. They all come together to develop systems which have a global impact. Okay, so that is where these things are headed now when we develop systems. Just as a side note for you. Okay, so when we talk about software engineering, it is no longer at these lower levels of this stack. It's going all the way to the society, all the way to the top. What you're doing now. I get some echo. Okay, so I'll skip the layers there. Okay, so let me mute somebody here because I'm getting echo. Okay, if there's echo, let me know. Okay. So that's why when we talk about the system designs, it tends to be very holistic. Okay, and there's an impact. Nice example that he gave here, right? When there are some regulatory changes, like if you take drug development, right, in pharmaceutical companies, drug development and delivery that happens, whenever there are some regulatory changes, it impacts the business processes, it impacts the development, it impacts your testing cycles, all the way there's a ripple effect. In US, for example, in the medical field, we have a standard called HIPAA. You can Google up HIPAA. Okay, that is a healthcare standard. When that standard was imposed, what it basically meant was all the associations, organizations which are involved in healthcare, they needed to follow some more stringent accounting practices and other business practices, which did not exist before. Okay. Now, one of the important things about HIPAA is it impacted how system requirements are gathered. It impacted how system is designed, tested, rolled out, right? So all those things get impacted when we're talking about the software before. Okay. So that is what this is trying to tell you. Okay. A lot of regulation, a lot of compliance issues would come into play. Okay. And now this one you would understand, right? So if you look at nuclear systems, right, or air traffic control, very important. You don't want air traffic control systems, if they're not regulated, you will have too many accidents in airspace. So there are some regulatory bodies which take care of those things. Now, wherever there is regulation, that would have an immediate impact on software development. See, in a roundabout way earlier when I was talking about dependability, right? But what redundancy basically means, you have more than one copy of what you do. We talked about it in the case of databases, right? When we discussed dependability, I said you replicate your database software in different places. So that way, when one database goes down, you can bring up the other database. Okay. So depending on the business need and depending on the criticality of your system, you have to plan redundancy. Okay. Now, how do you plan redundancy? What can that, hey, I need to worry about redundancy, right? I'll give you an example of redundancy. Boeing, if you look at Boeing plane, right, airplane, do you think there's a lot of redundancy in a Boeing aircraft? If so, what could it be? Can you give me some example? Give me one example in the context of an airplane. You all flew airplanes, right? Almost all of you flew a plane. What could be some redundant elements in an aircraft? Question is open to faculty as well. One second. You are on. Okay. Sorry, Andy. I
I believe
unmuted
the
you. Go
engine
ahead.
should be redundant.
For
Yeah, I believe
starters,
engine should
engine
be
should be
redundant
redundant.
first.
Absolutely. Absolutely. Actually, that's an interesting observation because in US, there are a lot of individuals can afford these small planes, right? Flying is a hobby. So they fly these single engine Cessna planes. I could never understand how one can go high up in the air in a single engine. And all the wiring in a Boeing is redundant. Okay. So redundancy becomes absolutely critical. Okay. Where do you design redundancy in the normal e-commerce systems? You design redundancy because you cannot afford to have any kind of downtime. Amazon cannot afford a downtime. eBay cannot afford a downtime. Airline travel reservations probably cannot afford a downtime, right? So wherever there is a flip side of redundancy is diversity, which is interesting, but in reality that won't happen. This is where I say researchers in academia come up with ideas, but some of them are not really implemented practically in the real world. What does diversity say here? What he's saying, the author is saying, is to prevent or to show resiliency against external attacks. Your servers, you don't design all of them using the same operating system. You use Windows, you use Linux, you use MacBook Pro. What it means is, in one sense, you can Google a federated architecture to get more knowledge about that. In theory, it makes sense, right? Because, by the way, you do know that the most attacks happen on Windows machines, right? Because it's not because Windows is vulnerable compared to Mac. It is, if you have 70 to 80% of the machines in the world are Windows, obviously there'll be more attacks there. Why do we want diversity? The reason why we want diversity is we are saying, hey, if the hacker by damage, okay, That is one of the reasons why we want diversity of the computing environment too. Okay. Same thing applies to process. So if your development process is, if you can diversify, meaning like for example, if you take validation and testing, okay. So you can have multiple ways of verifying your system all the way from design stage. For example, you can do design verification. It's not just pronged approach to develop dependable systems ultimately. Now again, wherever you want to achieve some things, the thing that you have to worry about is complexity, increasing the complexity of your system, plus the cost, right? So whenever you talk about dependability, the mantra that you have to say is, okay, I will develop a dependable system, but what aspects of dependable system you require, and based on how many of the elements of dependability you do not have a process, then every time you develop a system, you never know whether it works or not. Okay. So you should have a well-defined, repeatable software process. Remember how much I stressed on this, right? I said, hey, whenever you have a requirements document, you are going to talk about what are the use cases, right? What is the data? If you recall, I gave you 2 or 3 elements of that. So to me, that's a high level process. But in our software engineering world, we have come up with process frameworks. Steps are repeatable. Okay, that there's a thing called CMM and CMMI model. Check them out. Capability maturity model. Google up capability maturity model. It gives you levels of maturity that organizations may have in terms of implementing software processes. Okay. Now, whenever you're doing that, the whole idea of having a process is standardized. Okay. Every single project, you follow the same steps. Same documents are produced. Okay. It allows you to build robust systems. You will have documentation which is standardized. Okay. We also say process should be diverse, meaning it will give you some ideas about how to diversify your platform, your technology stack. Okay. And then it should be auditable. Ultimately, what happens is there are some standard bodies. Remember, you talked about ISO 9000 certification, ISO 9001 certification. Check the requirements. Okay. Have formal specifications. Okay. All of those things are basically process type of activities. Okay. I don't. Okay. Now, I do not know how much of formal methods are used today, but there is this entire body of knowledge on formal specifications. I'll also use the words formal specifications here somewhere. You can Google that up. I'm reminded of a book that I used as a He has given a very interesting book, wrote an interesting book on formal specifications. There have been some, I would say, group of scientists, computer scientists, who came from predominantly math background. You know, all early computer science departments were math professors, right? And what do math professors do? They are always interested in proofs, specifications, and all that. So they said all programming can be boiled down to formal specifications. So by practicing formal methods, you'd be able to come up with dependable system. That is what we are saying there. Okay. Science classes now. When people come to the programming language course, and nobody talks about formal specification procedure before they write code. Okay. But the theory exists for that. We call them preconditions, post conditions, and all that. I'm not going to go there, but if you are interested, if somebody wants to know more about it, any students want to know more about it, I can give them some guidance outside of the class. Okay, I'll skip the formal part of that. Okay, I'll stop here. Questions, comments on this chapter? If you see somebody holding the kung fu stick, that's my daughter there. She just came down to have a dinner at 11:15 p.m. in the night. Okay. So the key, what are the key takeaways from dependable systems? Is dependability a good feature to have? Absolutely yes. Right? The second thing, I know some students, somebody came forward. Okay. So dependability is an absolute critical thing to have. Okay. Now, the second thing that we learned is dependability is really dependent on your business objective, because remember, to develop dependable systems is a very time consuming, expensive proposition. Okay. So when you're gathering your requirements as an analyst, one of the things that you want to say is, hey, what aspects of dependability are important to you? How important is security? How important is availability? How important is redundancy? Multiple layers and perspectives, right? There is a hardware architecture, there is a software architecture, how you divide your software. There's a complete network configuration. So architecture permeates different levels of abstraction. Okay, that's another aspect of it. And then we also talked about saying that no one person, a programmer, may not have all the skills to design a dependable system. Programmer is good at coding, but you need a diversified set of distributed databases, right? So it's truly a collaborative team which can develop highly dependable systems. Okay. Anyone has questions, comments, come forward. I will unmute people here. I have unmuted JNTUV. Cheppandi.
Sir, For the dependability aspect, can you just give a briefing on the data level dependability in terms of vulnerability? I'm saying, sir. To alleviate the vulnerability that is at a software level, the cost that is incurred to alleviate the vulnerability at the system level. Just can you just throw some light on that?
Oh, absolutely. So what happens is, right, remember we talked about the layered architecture, right? So let me take a new slide here. So let's see, where am I? Okay, let me just do a new slide. So what did we say? We said when we talk about the layered architecture, we start with layer, quite honestly. And then you have application, right? Your application, whatever you're developing, and then you have the enterprise as a whole. And then whatever your enterprise is doing in the holistic system, we said it has an impact on society, correct? Now, when my goal is to develop a dependable system, let me take an example here. Let's say, let's say I'm developing a context. We need to have a context. Let's say I'm developing is it Flipkart, which is called the e-commerce marketplace in India? I think it's Flipkart, right?
Yes.
Okay. So let us say I'm in charge of developing Flipkart. Okay. Now, at the highest level, is dependability important in Flipkart? I say is dependability important? Now the guy would say, okay, what do you mean by dependability, right? Because the guy would have no clue what dependability means, right? Then I would ask him, okay, do you want the system? Remember, we had the dependability diagram. Do you want it to be reliable? Do you want to keep it available all the time, right? Do you want it to be secure? Okay. I keep asking them these questions. You're with me so far?
Yes, sir.
Okay. So once I know what the answers are, I mean, in the case of Flipkart, what would he say? Hey, he would say the system should always be up. Okay. The system should be highly secure. Let's take those. Then drive the following things. System should always be up means I know that database has to be That means I have to build some redundancy, right? At the database layer level, right?
Yes, sir.
Because if one database goes down, I should be able to immediately bring up the other database. That is a data layer, right? Now, the other thing is, should the hardware be replicated? Hardware servers? Whenever the users are hitting a web server, there is a scheduler. It keeps scheduling between different hardware machines. Because if millions and millions of users are accessing one hardware server, the performance degrades, right? So now you know that you need to have the hardware replicability, right? So that is how you build your architecture.
Sir.
Okay. Now, so it is to. Now imagine if it was not a flip. Maintaining a student roster along with their semester assignments and grades. How dependable that should be compared to Flipkart. I don't think I need a database replicated there, right? I don't think I need a hardware replicated, correct?
Yes, sir.
Big changes, right? That is the reason why this entire thing on dependability is so important for software engineers. We didn't learn this so far, right? Because they just developed some midterm, we did some examples. But in real life, when you go out in the field, these types of questions become more relevant. Okay, I see a lot of students behind you. If they have any questions, ask them to come forward and pose them. Unless it is too easy for them.
Actually, they are looking forward for the transcripts. Actually.
Okay. Okay. Good. Great. So please. Your time. And then the following Monday, there will be students who will be selected to present their projects. The project would be one of the three. Remember, we talked about how to convert the midterm into a project, right? I'm going to send an instruction as to how a project report should look like and how the presentation should look like. And the following Monday, 9th of November, each classroom, Chakravarti Garu said you'll all provide some snacks to the students like samosas and all that. Okay. And then some groups will present and we'll enjoy their presentations. It'll be their turn.
Yes, sir. Yes, sir. Finally, your midterm exam starts, sir. Second mid. After midterm, is it okay, sir?
Yeah, after midterm is fine because నాకు మూర్తి గారు చెప్పిన దాన్ని బట్టి 9th November is the last day of the semester, right? చెప్పండి. తప్పకుండా అండి. మీరు you tell me when they'll present the projects. And then and one more thing, Tirmal Rao garu, since all the faculty are here, Chakravarti garu has announced 5 prizes for each college. Somewhere here in the chat
that's
he put
great
there.
news.
And remember, and I also said I'll give some gifts to the top 3 presenters. Okay.
Yes, sir. Students are happy, sir.
So students, it is all for them only. Students, and you'll get very clear instructions. Okay. చెప్పండి. Amazing.
Thank you, sir. Thank you very much.
Go the same, Andy. I think I said that in the beginning when I see a room full of students, that's very inspirational to me. Does not mean the other colleges are not inspiring me. They are. The one with uniform?
Yes, sir. Yes.
There you go. See, very nice. I thoroughly enjoyed this. So I will talk to you again Sunday night my time. That will be Monday morning your time. And I will post these files in the community after this class.
Thank you.
Okay, Andy. Good night. Rather good morning, and
Thank you,
have a
sir.
wonderful day, all of you. Bye. Meeru, you can call me even now, Andy. I won't sleep for another hour and a half. Okay. Take care. Bye.